This is part 2 of my solar shed project, and this one I'm going to attack a lot of the hardware that gets put into the shed. So first just looking at making a panel to mount all the components on in the shed. Then next I'll have a look at the getting the Renogy Solar controller connected to a Raspberry Pi so that the Raspberry Pi can get some basic data details off the Renogy controller, and making sure that can be done from Python. Third part of this, I'll have a look at relays. I'm going to be using both latched and unlatched relays for being able to make sure I don't use too much power when I'm turning the relays and things on and off. So we'll have a look at that. And then finally I'll put everything together in the shed. So drill some holes in the shed and mount the panel and the components and get the initial version working so I can see how much power I'm actually generating, how much I'm using in the shed. So this will be most of the components before I actually put a ham radio out there. I'm going to mount everything on in the shed next to the door. So I'm going to make a panel. So first I need to make just a straight edge on the panel I'm going to use. Yeah, that's looking pretty good. So I'm going to make another straight edge about 90 degrees to that straight edge. So I've got a little bit extra I just want to cut off. It's in the way in the workbench. And then I've got this 90 degree straight edge to the other one as well. So that will help with measurements. Then I'm going to cut it down to the actual width of the area next to the door in the shed. So I got close with this cut. And I'll just straighten that up a bit. And this is what it looks like in the shed. Don't think all my things are straight in the shed, so I may have to work on it. But here's the panel, and I just laid out the components I'm going to use. I think the layout will be kind of like this. So the central to it is the solar controller. It's going to talk RS232 to the header on the Pi 3. Then I'm going to have solar coming in from the top, solar power coming in from the top. Then the battery's going to connect to this connector at the bottom. And then finally the power out from the solar controller will go both to the webcam and down to the radio. The other pieces I need is I'm going to connect the headphone and the mic jack on the radio to a sound card on the Raspberry Pi, and also connect the CAT interface, which is serial, to the header on the Raspberry Pi. So I'm making progress. I got the panel together, but now I've got to dive into the electronics a bit more. So something I need to do is to be able to have the Raspberry Pi talk to the Renogy Solar controller. It does that through RS232. So next 7 minutes or so I'll just go through the hardware and the software I needed to put together to get that working. Hey, this shows the circuit I used for interfacing the Renogy to the Raspberry Pi serial interface. So it uses Max 3232 TTL to RS232 voltage level board. These things are pretty tiny and they're kind of weird. They have circuits on both sides. So the best way I found of using them was actually to connect up a header to each end. I'm only going to use half the board, but I found just using surface mounting techniques and melting solder there allowed me to put the header on and then just manually solder the power, and then I did the same to the other end of the board and it was all set. So this shows you it all set up on my breadboard, connected up to the Raspberry Pi, going through the Max 323 and then connecting to a RJ11 interface, which connects to the Renogy Solar controller. So I put together the RS232 to a Raspberry Pi interface I needed to be able to get the data off the Renogy Solar controller. So let's have a look at the program that does that. So I've SSH'd into my Raspberry Pi. I'm going to gedit this testsolar.py program so we can have a look at it. So they'll fire up gedit in the next Windows window, make it easy to edit. So here's our X Windows gedit window showing this testsolar.py. So some of the things I'm doing is I'm using pyModBus library, and I'll show you a bit more about that. But the RS232 interface on a lot of controllers, and in particular on the Renogy controller, uses this ModBus interface. And I'll put some links in and show you a screenshot of where you find out more about ModBus. But it's fairly common RS232 bus to use and supporting protocols. So I make a ModBus client and define what serial interface it is on my Raspberry Pi. So for me it's the dev serial 0, the baud rate, and connect to it. So I do a read of the registers, and again I'll show you the register layout I found on another document. So I'm going to read 35 byte content of the registers started at hex 100. I'll print those out, those registers, just so you can have a look at the raw registers, and I'm going to get the data that's in those registers. So again, that mapping for the register is going to help work out which register contains what information from the Renogy's controller. And then I'm just going to print out each of those details. So this is going to report on the things that I'm going to be interested in for the web service I'm going to put over this. So the current battery capacity, the battery voltage, the solar power coming in watts, the power going out of the solar controller in watts, and I'll also keep track of the voltage and current going out of the solar controller. So let's try running this just on my hacked together circuit first. So in this test setup I've got 13 volts going into the battery input on the Renogy controller. I've got a whole bunch of 10 watt resistors on the output that I can dial in with different resistances. So at the moment they're all in serial, so I've got 60 ohms of resistance here, and my meter is showing the current output amperage. So when I collect the data off the Renogy using the RS232 output, I can see that it's measuring the same output amperage as my multimeter, as well as the voltage. So I'm going to drop the resistance on the output down to 40 ohms, so basically just having 4 resistors in serial. And you can see the amperage goes up to 0.315 milliamps. Let's try one more with just 20 ohms on the output. So now we're drawing 0.625 milliamps, and let's compare it against the output for my program. One of the useful documents for putting this together was Renogy publishes the details of how they use ModBus. This is a document here, you can get it, I'll put the link to the Google having more information about it, but here's what I was talking about before, is kind of the breakdown of register locations and what they contain. So if you run through that, you can work out what registers you're collecting, especially just start at 100 hex address, and you get most of the important ones in the first few registers. There's lots of videos on YouTube about ModBus. I found this guy's one was pretty good, nice and simple, and kind of explained what you need to know about basic Modbus for pulling data from registries. So a couple of other web locations that I found useful was first this one, and I put the link down below in the description, and then from here there's this website which had more details about actual implementation and linked to Python code, which I kind of stole from to get the interface to the Renogy working properly. Again, all the links are down below. Our last stage for the RS232 interface was I used one of these prototyping shields. You see it fits on top of the Raspberry Pi like this. You can mount it with a socket. Makes it clip on pretty nice to the Raspberry Pi. And then I populated this with what I had for the RS232 interface on the breadboard, which made it a lot more solid and easy to connect up to the Raspberry Pi. So I have the Raspberry Pi talking to the Renogy Solar controller through RS232. So I wanted to wire up the panel a bit more, so let's just have a look at how the panel's looking now with the Pi shield with the interface on it and the main power connectors between the various components on the panel. So the battery connects through a screw-in connector at the bottom of the panel. I've got 3 inputs from solar panels, so I can have up to 3 in parallel. I break out the 12 volts coming out of the controller that can be split into 3 12 volts. Same thing for the 5 volts out of the solar controller, and also the other 5 volt output goes to the Raspberry Pi. So you might have seen on the panel I put together some 3D prints for mounts to be able to mount things like the Raspberry Pi and the other components to the board. So these were done in Fusion 360 and then printed out on a 3D printer. I'll put the files in links down below in the description if anyone wants to print some of these things off, but these are the mounts for the 2 relay boards in the Raspberry Pi. So the last components I wanted to get on the panel were the relays, so I'm going to be using a latching relay and a non-latching relay on the board. So I'll run through those components and some of the decisions I made along the way to save power for some of the choices I made. So I'm going to use 2 types of relays on the project. So one is the normal latching or unlatching relay module. These are fairly common, it's 5 volts. The only thing I was worried about with those is they use quite a bit of current when they're turned on. See, they use 75 milliamps just to turn on the relay. That's used all the time. So I'm going to use this for the radio because the radio uses a lot of current anyway and I won't be using it often, so 75 milliamps won't be a big deal. But for the webcam, I want that to be able to be turned on off all day, so I don't want to have a drain of 75 additional milliamps for running the relay for that. So I'm going to use one of these latching relays, and what you can see here is it actually latches into place and doesn't use any power when it's latched, so I can just connect to each coil and get it to switch between the 2 switch positions. So I was looking at the 2 coils that switch it between the 2 latched switch positions. You can see they've got a resistance of about 167 ohms. They're independent coils, and then here you can see the actual switch or latch that I'm going to connect the power going in up to. Okay, to get this working I really need to put a driver circuit between the Raspberry Pi and the coils on the relay, otherwise too much power will be drawn. So I'll be using one of these opto couplers and kind of a fairly standard circuit for isolating and powering the coils from a Raspberry Pi. So you can see, at least for one of the coils, where the whole thing's working and switching between the the latched and unlatched state. Finally, I wanted to test out my latching relay driver with a Raspberry Pi. So this is the GPIO enabler Python program I'm using from Raspberry Pi, and I've set this up to capture the current used on the GPIO pin. So let's run that program, and we see it flipped the relay, and it uses 4.3 milliamps of current. And I'll just reset the latch, so all looks good. So I transferred what I had on the breadboard over to this PCB. So I had to put 2 driver circuits on it. So I connected it all up. And then I made this quick Python program just to toggle the various GPIO pins to turn the 2 relays on and off. And here you see it's all being tested here. So it turns on the webcam using the latching relay, and then turns on the transceiver just using a normal unlatched relay. All looks good. So things are going about as good as they can. I've got my mounting panel with all the electronic components I'm going to use at this stage. Hasn't got the transceiver on there yet, but everything else I need for the solar power. And so I'm going to take that out to the shed, just sort of trial mount it in the shed, and also run wires for the solar panels and connect up the battery and run it out there for a few days just to see that the panel's recharging the battery enough to keep everything alive. See how much power I'm actually generating from the solar panels out there. So putting everything together on the shed, first thing I wanted to do was put a hole for the external solar panel connector. So I drilled out from inside a little pilot hole first, just to make sure I wasn't going to hit anything on the inside. I missed by a bit. I thought I'd be about 2 inches further over and 3 inches lower, but never mind. Just I didn't put it on one of the fake plank indents on the outside. So for the solar panel connector I'm going to use, I need about a 3/4 inch hole. Stay drilled through there. That's good. I'm paranoid about putting holes in the shed, so I wanted to seal it up as well as I could. So I'm going to just paint the raw wood that I exposed here, and then when I put the actual connector on, I'll seal it with some silicone as well. But I'll put a lot more than I need on here just to try and seal up the exposed wood as much as I could, or the raw wood. Yeah, I think that'll do. And I'll let that dry while I get some of the wires in place inside. So here's the hole when you look from the inside. So next thing I'm going to put that panel I created up next to the door in the shed. I want to be able to easily take this down later, so I'm just going to put 2 screws in at the moment. And all the connectors to the wiring in the shed, either screw connectors or clip down connectors, so it should be easy to take it out when I want to do some more work on the Raspberry Pi programming. Yeah, we sped this up a bit. Not that exciting watching drilling holes. Probably wasn't that exciting watching the painting either. There we go, the panel's in. So I'm going to run the solar wire from here. I'm going to use a little terminal clip to do that. Well, while I was doing it, I found a whole bunch of ants up in the corner of the attic. So I'm glad I found that. I gave them a spray, and then I'm going to put some of this ant killer bait up there as well and keep an eye on it. But now I've run the wires over to the solar controller input. Now on the outside, this is dried enough. I'm going to put the external connector in. Fits fairly snugly in the 3/4 inch hole. It looks good. So it takes 4 small screws to put it in place. I'm going to drill one of them, screw it in just so I've locked in the position, and then I'll drill the holes for the other 3 screws. First screw out, and like I said, I'm going to put some silicone all around it, going to try and make sure no water gets in between the connector and the boards on the outside. Yeah, that should do most of the job, but I'll put a bit on the connector as well. There's a little flangey bit there that might be good to have some silicone around as well, but that should keep the water out. Also should cover the screw holes I've got there, so I'm pretty confident the water's not going to get in through there. Now I can screw it down. As I do this, if I see some silicone squelching out the side, I know I've got a pretty good tight fit. There shouldn't be any gaps between the boards and the connector. That's good. Some silicone squeeging out there. That's nice and firm. Now I'll just run the extra silicone around the outside to make sure everything's sealed. Now I connected up the wires coming into that connector at the bottom. Next up was the battery. So there's a 12 volt 18 amp battery. So I need to put some terminals on the end of the wires that are going from the battery up to the solar controller. So I bolted those to the battery, so they should be on nice and firmly. And then I'll run the wires up to the solar controller. Here's everything connected up. Here's the battery. I'll put some more clips for the wires in as I'm happy they're in the right place. And as soon as I connected the battery, the solar controller fired up, and I have the panel connected as well. So I'm seeing 17 volts coming on the panel at the moment. So it was late in the afternoon, so I wasn't really expecting a lot of power. And here's where we have it at the moment. So we'll see how it goes tomorrow, but at the moment I could come back inside connect up through Wi-Fi, and get my stats off the Renogy controller just the same old way. So I'll check how things are going out in the shed over the next few days, but that ends part 2. So part 3 I'll be starting, and what I want to do is do a lot of the coding. So do the Python side first, and there's actually 2 components in that. There's going to be a Python daemon that kind of looks after everything in the shed, and then I'll put together some web services. So that'll be most of part 3 that's coming up. And then once I've got the web services, part 4 will probably be about creating an Angular client to talk to those web services and sort of expose everything that's going on out there.